Okay, so today we're going to talk about area between two curves. And so it's the very first day of the unit. And literally, it's stuff we actually have to know, but I'm putting stuff together. So, think about this. If I have this area, this curve F, that's this curve right here, and its shaded region between A and B is right here. And hopefully you get that, and that's why the area of F is from A to B of f of x dx. Hopefully that makes sense. Now let's talk about G. So G is this graph right here. And if I'm talking about the area for that graph, that means that I'm talking about this area from A to B. That's this area right here. So that's this area. Well, what happens if I want literally this area? How do I get this area? Well, wouldn't that be the area of F minus the area of G is going to be what's left over. So, F of G, F minus G from A to B. So the area between two curves is going to be the area of F minus area of G, or the integration from A to B of f of x minus g of x. Now sometimes we'll give you A to B, sometimes it's where they're going to be intersecting. It all depends on what we give you. So let's talk about Riemann sums. Now again, remember about Riemann sums, now it's just you need to be able to recognize pieces. But again, if this is my area right here, if this is the area that I'm talking about, it's between these two graphs. So notice that this is the area that I'm talking about. That's why there's an A there. I'm going to take F, which is the top curve, and subtract G, which is the bottom curve. Well, how do I do that? It's a series of rectangles. So here's my F minus G, F of x of I minus G of x of I. Delta x is again that difference between the x values. The summation of I going from 1 to n, because I have an n number of rectangles. That should look familiar. And then I want that n to go to infinity because I want the smallest amount of rectangles possible. I'm sorry, not the smallest amount of rest, but the most amount of rectangles possible, so they're the smallest rectangles that there are, but the most amount of rectangles so that I cover everything. So that's why the limit as n approaches infinity is the summation of I going from 1 to n f of x of I minus g of x of I, all times delta x, is the integration from a to b of f of x dx minus g of x all over delta x. And again, this is really what we talked about. You need to know now summation and what pieces go with it. You will not have to do another summation the whole way through. You need to be able to recognize things. So here's the first example. Example 1 says, find me the region bounded by the curves y equals x squared plus x plus 2, y equals negative x equals 0, and x equals 1. So y equals x squared plus x plus 2. I've actually graphed it for you. It's in red here. Y equals negative x. That's a line. That's in green. X equals 0 is not up yet. So let's graph x equals 0. That's a vertical line, ladies and gentlemen. That's going to be right here. And then x equals 1. That's a vertical line also. That's right here. Which means that the area that I'm talking about is literally going to be this area right here. Here's what you need to know. Whenever you're doing these, you just need to know what's the top and what's the bottom. So the top is literally going to be the red. Y equals x squared plus x plus 2. And the bottom is literally going to be the green. Y equals negative x. And my A is my very first x value, which is 0. And my B is my very last x value, which is 1. So my integration, ladies and gentlemen, is going to be the integration going from 0 to 1 of my top, x squared plus x plus 2, minus my bottom, negative x, dx. So, the integration from 0 to 1 of x squared plus x plus 2 plus x dx. So, the integration from 0 to 1 of x squared plus 2x plus 2 dx. So that's going to be x cubed over 3 plus x squared plus 2x evaluated from 0 to 1. 1 cubed over 3 plus 1 squared plus 2 times 1 minus and literally 0 because all of those are going to be 0. So that's going to give you 1/3 plus 1 plus 2, 3 and 1/3 or 10/3. There's my area. That's how much my area is. My area is 10/3. So let's talk about number 2. Number 2, I said find the region bounded by the curve y equals 6 minus x squared and y equals x. And again, normally I'm not going to give you a graph. You're going to have to figure out what the top and what the bottom are. In this case, I was very nice and I gave you a graph. Y equals 6 minus x squared is the curve that is green. And y equals x is the straight line in red. Here's the issue. I can obviously see what top and bottom are, but I don't actually know what the A and B are. So let's talk about how to find those. I'm going to do it 2 different ways. So I'm going to first mark that the top, in this case, is going to be the green, which is y equals 6 minus x squared. And the bottom is going to be the red, which is y equals x. Now, I don't take you anywhere else, so if I want the area between the two curves, you'll notice that this is the area that I'm talking about. This is all this area right here. So what do you literally need to know? You need to know where these two graphs intersect. So I'm going to talk about where these two graphs intersect and how do I find where two graphs intersect. I literally set them equal to each other. Now I'm going to move it so that my x squared is positive because I like to solve things when x squared is positive. So I'm moving the x squared to the right hand side and I'm moving the 6 to the right hand side. That gives me 0 equals x squared minus plus x minus 6. And when I factor this, because I can factor this into 2 separate pieces, I'm going to get x plus 3 and x minus 2 equals 0, which means that x is equal to negative 3 and 2. Well, if you look on my graph, ladies and gentlemen, the x value where they intersect is negative 3, and the x value where they intersect is 2. So you could have just read the graph. Normally, I'm not going to give you a graph. So now I have enough. Now I can write my equation. My integration symbol is going to go from negative 3 to 2. My top was my 6 minus x squared. My bottom was x dx. When I do this, you're going to have the integration from negative 3 to 2 of 6 minus x squared minus x dx, and I can integrate that. This becomes 6x minus x cubed over 3 minus x squared over 2, the value of negative 3 to 2. Which is going to give you 6 times 2 minus 2 cubed over 3 minus 2 squared over 2 minus, let me down, space, 6 times negative 3 minus negative 3 cubed over 3 minus negative 3 squared over 2. 6 times 2 is 12, 2 cubed over 3 is 8, 2 squared over 2 is 2, negative 18, 3 cubed, negative 3 cubed is negative 27, divided by negative 3 is negative 9, but that makes sense plus 9, and that's positive 9, so that's negative 9 halves. So now I have 12 minus 8 thirds, plus 18, because this is negative 9, which makes us negative 18, and then minus 9 halves, plus 9 halves, because the negative is positive, so I have 19 plus 9 halves minus 8 thirds, everything needs to be equal 6s. I'm just going to do these in 6s, so this is 6, which makes this 27, and this is a 6. Oh, got math in my head, 2 is 16. So 19 plus 11 over 6 19 times 6, well 20 times 6 is 120, so 114. Over 6 plus 11 over 6, which makes it 9.5 over 6. Now, here's something that you need to recognize. Even though this area had negative area, the area between two curves will always be positive. The area between two curves will always be positive every single time. One thing I did forget to write that I wanted to write over here, nope, wrong screen. Area between two curves is going to be the top minus the bottom. We're going to talk about it could be one other thing, but in general it's going to be top minus bottom. And so you'll notice that we did top minus bottom. I'll set up the next one. Again, area is non-negative. It's still going to be negative area. It's still always going to be a positive because the negative area is bounded by y equals 0, y equals f of x, and y equals a and b. That's why it's all positive area between two curves. The area of this one is going to be negative 1 to 2 of 1/2 x squared minus 2 dx. And I'm going to let you, for lack of, because in time, let's talk about using your calculator for this one. So I'm going to grab my calculator. And I'm going to type this into my calculator. Alright, so I typed in my calculator, but you know what I forgot to do? Because I forgot to check. I forgot to talk about the x-axis. That's what I forgot to talk about. So, by the way, my answer is wrong. Because this is wrong. I didn't talk about the x-axis. If you think about this graphically, if I think about y equals 1/2 x squared, that's going to be down here at negative 2. And if you think at like 2, that's 4, that's 2, that's 0 right here. So that means this graph looks something like this. And I'm cutting at negative 1 to 2, which means I have to talk about not 1/2 minus x squared minus 2. That's actually not right. Because the top of this is not 1/2. The top of this is the x-axis, which means it's 0 minus 1/2 x squared minus 2 dx. Which changes how I stick this in. And if you haven't guessed already, what it's going to do is I'm going to put a negative parentheses right here, because 0 minus, and oh, look what it did. And now you'll notice that now it is a positive 4.5, which should make sense now because we are talking about area under a curve and it's under the x-axis. So the area, again, that I was talking about, so this is 4.5. The area that I was talking about literally is this area right here. It is underneath the x-axis, but because I'm also bounding it by the x-axis, it's not considered to be negative area. So for this one, again, I'm going to set it up, and I'm not going to actually do the math because we can talk about it. I am bounding the region between 0 and 1. If you think about x squared plus 2 and negative x, which one's going to be on the top? This is going to be the top because it's positive. This is going to be on the bottom because of the way the things are located. You want to check, you can check over here. Here's my graph. The x squared is on top. The x squared plus 2x is on top. And the negative x is on the bottom. So I'm going to have x squared plus 2 minus negative x dx. And because of timing, we're just going to stick this in our calculator. Some of these will be on calculator. Some of these will be on non-calculator. We're going from 0 to 1. X squared plus 2 minus negative x. Now I can obviously do the math there and make that just plus x. I'm literally writing it out to show you that I can have it all. And then I'm going to do this so that I have the answer of the fraction. And you'll notice there's my answers. 2.833 if you're rounding it, or 17/6. And that is the shaded region right here that says the area between these two curves. Find the area of the region bounded by g of x equaling 2 minus x squared and the line f of x equals x. First, you need to find the points of intersection. I too agree with that. There's a hint right there. And so I'm going to find my points of intersection by literally setting them equal to each other. So 2 minus x squared equals x. I'm going to move everything to one side. I am moving it so the x squared is positive. It makes it so much easier when I'm going to factor this. I have x plus 2 and x minus 1. So I have x equals -2 and 1. So those are my two values that I'm going to have. And now my question is, which one's on top? And literally, you just need to do a quick sketch of where things are located. 2 minus x squared, that's an upside down parabola. Y equals x, it goes to the origin of something like this. And ladies and gentlemen, literally as a quick sketch, it does not have to be exact, but oh look, what's on the top? The top is 2 minus x squared, and the bottom is f of x. So I would set it up. It's going from -2 to 1 of the top, 2 minus x squared, minus the bottom, which is x, dx. And right now you can totally stick that in your calculator because we're not going to take the time to do all of them. So -1 to 2, 2 minus x squared minus x dx. 22. 2 minus x squared minus x. My area is 1.5. Alright, so let's try a couple others. So let's talk about number 6 and talk about not having a calculator to do this one. So it's really important that you talk about where this is located because that will make a difference for this one. So if I talk about graphing this, here's what's the mark? Change my mark. Sorry. Here's pi over 2 and here's pi because I typically do 0 to pi. Here's 0, pi over 2. This is sine graph. The sine graph starts at pi, goes here and here and here. Okay. So if I blow this up and I'm only looking from 0 to pi over 2, here's the sine graph. Here's the cosine graph. What do you need to know? Because if I'm talking about the area between the two curves, ladies and gentlemen, I need you to recognize a couple things. That the area between the two curves is not right here. That is not the area between the two curves. Not going from 0 to pi, that is not the area between the two curves. The area between the two curves is from 0 to pi. Is this area right here? And it is this area right here. And I need you to recognize that they are different areas in terms of where they're located. Okay? And I also need you to recognize the top and bottom are different for both ones. I also need to know where they're equal, because that's where they're going to intersect. So I literally need to know where does sine x equal cosine x, and that's at x equals pi over 4. That is why right here is pi over 4. Well, ladies and gentlemen, that means that the integration is going to go from 0 to pi over 2, and the top of this yellow piece is the blue, and the blue is cosine. So cosine x minus the red, sine x plus integration from pi over 4 to pi over 2. And in this case, on the green portion, the red is on top. So sine x is on top, and then the blue is on top, minus cosine x. If you just go from 0 to pi over 2, you will not get the correct answer. It's kind of like when you do velocity. Your velocity has to be in two separate pieces because of where it intersects. That would be this one. Remember opposite value velocity? Alright, so I'm going to write it down here so I have room. Cosine minus sine from 0 to pi over 4, and then pi over 4 to pi over 2 of sine minus cosine. For this one, the integration of cosine is sine. The integration of sine is negative cosine, which means this is plus cosine x, evaluated from 0 to pi over 4. This one, the integration of sine is negative cosine. We just talked about that. The integration of cosine is sine, so that negative is going to stay, and that's from pi over 4 to pi over 2. So, the sine of pi over 4 minus, or plus cosine of pi over 4 minus the sine of 0 plus the cosine of 0. These zeros are important, they have to be there. Plus the negative cosine of pi over 2 minus the sine of pi over 2 plus the negative cosine of pi over 4 minus the sine of pi over 4. Sine of pi over 4 is square root 2 over 2. The cosine of pi over 4 is square root 2 over 2. Minus the sine of 0 is 0. The cosine of 0 is 1. The cosine of pi over 2 is 0. The sine of pi over 2 is 1. The cosine of pi over 4 is root 2 over 2. The sine of pi over 2 is root 2 over 2. This makes this 2 root 2's over 2's, or just root 2. Minus 1, minus 1. This makes this negative 1. This is negative 2 root 2 over 2, or negative 1 minus root 2. And I'm done. Hold on, I think I've done something wrong. Let me fix my math. Hold please. Miss Year figured out what you did. So, right here, probably most of you figured that out. That should not be a plus sign right there. That should be a minus, which makes this a negative 2 root 2 over 2, but it's a positive because it's negative, negative is positive, which makes this positive, which makes this 2 root 2 minus 2. That is a positive area. So you'll notice that sometimes if you think that's why a quick sketch has to be good, it has to be there. It doesn't have to be exact, it just has to be a quick sketch so you can figure out where things are located. So let's talk about the next one. And the next one right here, you'll notice that I have it set up for you already. So you actually don't have to graph it. You can. But I want you to recognize a couple things. In the red is the cubic, which is this one. In the blue is the quadratic, which is this one. And you'll notice that there are two different areas that you have to talk about. You have this area right here in green. You have this area right here in blue. And you need to talk about both areas. So, we're talking, I'm going to set up both of them for you. You need to know where they intersect. And you'll notice that they intersect right here, which is 2, 3, negative 3, and which is here at 3, and here at 0. And then you can also verify that by doing the math and sending them equal to each other and solving them. If I don't give you a graph, that's what you do. But my first one's going to go from -3 to 0. And it's going to start off with the red. So it's going to be 2x cubed minus x squared minus 14x minus. And then it's going to go to the blue, which is parentheses 4x minus x squared dx. And that is all green. All of that is green. And that is not correct. It is not go -3 to 3. It does go -3 to 0. Plus, here comes the other piece. So plus 0 to 3. Now the blue is on top. 4x minus x squared minus, or parentheses, 2x cubed minus x squared minus 14x dx. And I'm pretty sure now you can integrate both of those. I'm not going to integrate them right now, but you can integrate them exactly if you want to and get out your answer. Well, let's talk about what happens if it doesn't look pretty. So let's talk about the graph that I have over here on the right-hand side. The issue with this graph on the right-hand side is that they never intersect top and bottom. What they do is we can talk about it right versus left. So this is where we now talk about things in terms of the y, which means it is no longer y equals, it is now going to be x equals, and that's the difference here. It is no longer going to be y equals, it's going to be x equals, and it all depends on what makes sense. And you'll notice in general, are you going right minus left, or are you going top minus bottom? If you are top minus bottom, you are dx. If you are right minus left, you are dy. Which means you're in a, and you'll notice that if you are dy, these are y values. If you are dx, they are x values. So if you look at the first picture that I've given you, I'm going to talk about this in two different ways. I'm going to talk about it with dy's and with dx's. Dy's are going to be so much easier than dx's. It is a sideways parabola, which means these are not functions, and that's totally fine. But you'll notice that I have my function in two different colors, or my sideways parabola in two different colors. It is in red and it is in green, because one is the positive portion and one is the negative portion. If you go top minus bottom, the issue that I have, if you look at this graph, and you look at where top minus bottom is, okay, I have a top minus bottom, it's blue and green, it's blue and green, it's blue and green, it's blue and green, it's blue, oh, no, it's not blue and green anymore, now it's red and green. So that's why you have to have two different intersections, because I have a blue and green, and then I have a red and green. So if you were doing dx, it is going to be blue minus green dx plus red minus green dx. And if you're talking about dx, let's talk about these equations. So I have x equals, oh, no, it's not. I have x equals 3 minus y squared. That's not y equals, and I didn't have y equals if I'm talking about dx. So I'm going to solve this for y equals. So y equals 3 minus y squared equals 3 minus x squared. So ladies and gentlemen, you'll notice that I have y equals plus or minus the square root of 3 minus x squared. Or better yet, in green, or in red, I have y equals the positive portion of 3 minus x squared. And in green, I have y equals the negative portion of square root of 3 minus x squared. Which means, oh, and I didn't know where they intersect. Well, I can tell that on my graph because I graphed it for you. That would be 2. And over here, that would be -1. And over here, that would be 3. Oh, but let's actually put the ordered pairs because that will be beneficial. So this sort of pair is -1, -2. This sort of pair is 2, 1, and this sort of pair is 3, 0. That may be beneficial later. So if we're talking about the integration, we're starting at negative, x value? So -1. And then I'm going to the x value of 2, and it is blue. And my blue, let's run my blue, so x minus 1 equals y. So my blue is x minus 1 minus my green, which is the negative square root of 3 minus x squared dx, plus the integration from now 2 to 3 of now it is red, the square root of 3 minus x squared, minus my green, negative square root of 3 minus x squared dx. I don't know about you, but those are not easy to do, the square root one, because you don't have the x in front of them in order to use substitution, so it's going to be a pain to do that. But we're going to take this same picture, and now we're going to talk about it right minus left. And if I talk about it right minus left, I'm going to talk about that entire curve. So I'm actually going to bring it down here, and I'm going to do a quick sketch. And I had a graph look like this, and then I had a graph look like this. And this graph was x equals 3 minus y squared, x equals 3 minus y squared. And this one was x equals y plus 1. Now, ladies and gentlemen, I literally just care about this. And if you think about it, if I'm going right minus left, the right is the blue. The red is the left. I care about where they intersected. These are the 2 points that I cared about. This was -1, -2. This was 2, 1, if I remember correctly. Make sure I'm right. Yep, 2, 1. And now I'm literally going to set it up. The y values are what I care about, so that's -2 and 1. The right, 3 minus y squared, minus the left, y plus 1, dy. I can do this. This math I can do. This becomes -2 to 1 of 3 minus y squared minus y minus 1 dy, which just makes this integration from -1 to 2 of 3 of 2 minus y squared minus y dy, 2y minus y cubed over 3 minus y squared over 2, evaluated from -2 to 1, which makes this 2 times 1 minus 1 cubed over 3 minus 1 squared over 2, minus 2 times -2 minus -2 cubed over 3 minus -2 squared over 2. Makes us 2 minus 1/3 minus 1/2 plus 4. Negative, positive, negative, so -8/3. Positive 2, negative, so negative makes us a positive 2. Which makes this, and this make 8. This one and this one make -9/3 minus 1/2. That makes us 8 minus 3 minus 1/2, which makes us 4.5. That was a lot easier doing it than trying to do it by dx. Because if you try and do it by dx, then you're going to have too many pieces in there that you don't know how to do. So that's the whole point of drawing a picture to figure out which way is it going. Is it easier to do it right minus left or top minus bottom? In general, it's one of those two. So if I talk about this one, Find the area of the region bounded by the curve x equals y squared and y equals x minus 6. The first thing that I am going to do is I am going to kind of draw a picture, and then I'm going to talk about how to find the intersections. I'm going to do those. So x equals y squared. Well, I'll do y equals x minus 6 first. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If y equals x minus 6. X equals y squared is going to be a sideways parabola. Here's what I do, ladies and gentlemen. When I have to do one of these, I'm sticking in the y value. If I stick in 1, 1 squared is 1, I get out 1. If I stick in 0, I get out 0. If I stick in negative 1, negative 1 squared is also 1, so I'm going to get 1. If I stick in 2, 2 squared is 4, so that had to be 4. If I stick in negative 2 squared is also 4. Notice that I stuck in the y values, not the x values. You made it a little bit easier. So 0, 0, 1, 1, 1, negative 1, 4, 2, 4, negative 2. So I need to figure out where they intersect. I can easily set this equal to x equals, so I can easily make this y plus 6 equals x. Now they're both x equals, so y squared equals y plus 6. So now I'm moving everything to one side. I want my y squared to be positive. It makes it so much easier. Y squared minus y minus 6 equals 0. Y minus 3. Y plus 2 equals 0. So I get y equals 3 and negative 2. Ladies and gentlemen, if you look at this graph, the highlighted region is what I want to find. It is easier. It's not going to be easier to do top minus bottom because the blue is top and bottom for half of it. But I can do right minus left, and if I do right minus left, then the green is right and the blue is left. And that's going to be much easier. So I'm going to say right is going to be green, which means I need to have an x equals, and that would be y plus 6. And then the blue, left is blue. That was x equals y squared. Ladies and gentlemen, hey look, I have y values right here. Isn't that nice of me? There's my y values. Those are where they intersect. That's what I care about, where they intersected. So I'm going from negative 2 to 3 of the right, which is y plus 6, minus the left, which is y squared. Now, if I want to do this in my calculator, I could do it in my calculator. Negative 3 to 2. And instead of y, I'm going to just put x. I can do that. It's gonna act the same way. Oh, negative 2 to 3. Let me fix this. Negative 2, 3. Y plus 6, now I'm going to choose x just because it's going to be easier than doing y, minus y squared dy. It's going to act exactly like y does. So my area, 125 over 6. Alright, so again, it's the same thought process for this one. I'll set this one up and then I will actually finish it. But again, to do this, it's easy to find where they're going to intersect because they're both x equals, so I can set them up this way. To find out where they intersect, that's relatively easy. So I get 2 equals 2y squared. So y squared equals 1. So y equals plus or minus 1. Question is, what does it look like graphically? Again, I'm going to talk, I'll do this one first. X equals y squared minus 1. I am choosing y values. It makes it so much easier. I'm going to choose 1, I get out 0. I'm going to choose negative 1, I also get out 0. I'm going to choose 0, I get out negative 1. I'm going to choose 2, I get out 3, and if I choose negative 2, I also get out 3. So 0, 1, and also 0, negative 1, and negative 1, 0. And I have 3. Oh, because I got that point wrong. Negative 1, 0, I have 3, 2, and 3, negative 2. Makes sense? Side of the triangle opening to the right. Now I'm going to do this one. And again, I'm choosing y values, so I've got to choose 1 or negative 1. They both give me out 0. If I choose them 0, I get out 1. If I choose them 2 or negative 2, because they're going to give me out the same number, it is also negative 3. So 0, 1, 0, negative 1, and this is 1, 0, and this is negative 3, 2, and negative 3, negative 2. And I care about this area right here. And again, my right is going to be the green, which is x equals 1 minus y squared. And my left is going to be my blue, which is x equals y squared minus 1. So I'm integrating negative 1 to 1 of my right, 1 minus y squared, minus my left, y squared minus 1, dy. And you all can finish that. You know how to integrate from there and simplify that. And those are the notes for today.